Bohr's model of atom. It was in 1913. Let's have a look at the main postulates of Bohr's model. The first and the foremost is definitely the rectification of the Rutherford's model. That is, electrons revolve around the nucleus in fixed shells or fixed energy orbitals. In fixed energy shells, those shells are called as discrete orbitals. Now, what is discrete orbital? Discrete orbital is one which is having fixed energy level. That's called discrete orbit. And if the electron is having that amount of energy, that electron will be found in that particular orbit. That is how discrete orbital concept works. Second, while revolving in discrete orbits, electron do not radiate energy. So here it is categorically being mentioned that electron do not radiate energy or electron do not lose energy revolving around the nucleus. And third, Bohr called these shells at energy levels. So these are called as energy levels. So concept of energy level is being given by Neil Bohr. Previously they were called as orbits. Now they are called as energy levels, or you can say they are called as shells, energy shells. Now moving ahead, we have some other things to discuss about this model. Look at this picture. So this picture describes energy levels or different shells in an atom, right from shell number 1 that is immediate to the nucleus, that says it's shell number 1, K shell, and after that L shell, M shell, and N shell. The serial numbers are given against to the name of the shells. For K shell, N is equal to 1, that is the serial number of this shell. N is equal to 2 for second, N is equal to 3 for third, N is equal to 4 for fourth, and it goes on. Okay, so here is in the middle, it is a positively charged part of the atom that was discovered by the Rutherford. That's called as nucleus. So electrons are revolving in these shells, so according to their energy. If the energy is corresponding to the shell number 1, that electron would be found in the shell number 1, that's K shell, and accordingly if an electron is having higher energy, that will be found in the higher shells. Energy of the first shell is minimum, and energy of the last shell will be the maximum energy. And stability of the first shell is highest, and stability of the last shell will be lowest stability. So now we shall be discussing about how electrons are being distributed among these shells. That's called electronic configuration, or that was given by Bohr and Burry, and this is famously known as Bohr-Burry scheme. Now that is distribution of electrons in different orbits or shells. That's called electronic configuration. Let's have a look at Bohr-Burry scheme right now. Here we go. The first postulate that is very important to understand is the formula that will give you the number of shells in different orbits, and this is 2n square. Please make a note of it. So in this 2n square, n is the serial number of the shell. So you have on your screen serial number of different shells. For first shell, serial number is 1. So you will be placing n is equal to 1 for first shell and figure out what is the maximum number of electrons that can be accommodated in the first shell, that's K shell. And accordingly, you'll be changing the n with different values and figure out how many maximum electrons can be accommodated in different shells. So we are going to try this out right now. Let's have a look at first energy level, for which we will be placing n is equal to 1. Solve this formula, that is 2n square will be 2 into 1 square. That seems to be 2 only, isn't it? Definitely. So we got a number that is 2. It suggests that the maximum number of electrons in first shell, that's K shell. So K shell can hold only 2 electrons. It cannot hold 3 electrons. If there is third electron, that can be transferred to the second shell. Okay. So minimum 1 or maximum 2 in first shell. So for example, we have n is equal to 2. That will be 2 into 2 square. So that is 8. 8 is the maximum number of electrons. Maximum number of electrons in L shell. Okay. So you can solve it for 3. N is equal to 3. It will be 2 into 3 square. That's 18 electrons maximum in third shell. In M shell. And n is equal to 4 will be 2 into 4 square, 32 electrons in N shell. Okay, this is how you can calculate it. Now the second postulate that was given is the maximum number of electrons in valence shell. must be 8. What's valence shell? Here's very important concept coming up. Valence shell means last shell of an atom. Last shell of an atom is called as valence shell, and the number of electrons in the valence shell are called as valence electrons. Having 8 electrons in valence shell is considered as stability. And this rule is called as octet rule. Octet rule. Because it has been seen that in case of group 18, that is noble gases, like except helium, neon, argon, krypton, and xenon. Okay, radon is also, but that's radioactive. We will talk about the normal one. It's having 2 electrons in its last shell, and after that, every atom of noble gases, being it neon, argon, krypton, or xenon, okay, so each of these are having 8 electrons in their last shell. So they are unreactive, or we can say they are inert, they do not react. So it has been considered that having 8 electrons in the last shell, or having noble gas configuration, so or acquiring noble gas configuration is the criteria for stability of an atom. So that is why maximum number of electrons in the last shell can be 8. If it is less than 8 or greater than 8, so in that case the atom would definitely react in order to have 8 electrons, or to have 8 electrons in the last shell. An atom can either lose electrons or gain electrons or share electrons. So that is its valency. We have discussed that thing in the previous classes as well. So if you have not checked out that, I'll be giving you the link in the comment section, or I'll be giving you the link somewhere at the top. Moving ahead, filling of electrons in the shell is systematic. Filling of electrons is systematic, definitely. Once you are done with the first shell, then you can move to the second one, and then you can move to the third, and so on and so forth. Okay, so you cannot do like this, like you are filling electrons in the second shell and first shell is empty. Once first shell is filled, the extra electrons will be moved to the second shell. This is how it goes. Okay, so let's take an example of, suppose, say for example, we have boron, atomic number 5. It will be K2L3. So once K shell is filled, completely filled, it has its maximum number of electrons in it, then the extra electrons will be shifted to the second shell. And if second shell is filled, third shell will be then accommodated. Okay. So for example, we have carbon 6, K2L4, and nitrogen 7, K2L5, oxygen 8, K2L6, and fluorine 9, K2L7, and we have last one, that is we have neon, that's K2L8. Last shell is having 8 electrons, so neon is pretty stable, and every atom of an element in our periodic table tend to be stable, just like noble gases, just like elements in the group 18. So that's why to do so, elements may lose electron or gain electron or share electron. So that's called their valency, and that's why they react. That's why they combine with each other in order to gain stability. Let's take an example of sodium. Say for example, we have Na positive. We have sodium, atomic number 11, K2L8M1. After that, it has 2 ways to acquire stability: either gaining electrons, 7 electrons in order to have 8 in the M, or losing 1 electron. Okay, so it prefers this one, because gaining 7 electron is not possible for a metallic atom. So it's not that much powerful. Its nucleus is not that powerful that it can gain 7 electrons. So it prefers to lose this M1 in order to have K2L8. So sodium, after losing an electron, becomes K2L8. So this is the electronic configuration for Na positive. So we can say that Na positive is more stable than sodium atoms. Now let's understand about chlorine, atomic number 17. It is K2L8M7. Okay, either to lose all the 7 electrons from M shell or to gain just 1 electron to have M8. These are two options available for chlorine atom. So, being electronegative, it prefer to gain 1 extra electron in order to being stable. So, it gains 1 electron and it becomes Cl plus 1 electron becomes Cl negative, chloride ion. So if we figure out the electronic configuration for chloride ion, it is K2L8M8. Look at this, 8 electrons in the last shell. So we can say that Cl negative is much more stable as compared to Cl or as compared to chlorine atom. Chloride ion is more stable. Now we have two species with us. One is Na positive, another is Cl negative. Na positive, the electron lost by Na is gained by Cl negative. These two come close to each other. Being charged particles, they are being attracted towards each other by a force called electrostatic force of attraction, and they form NaCl, that is sodium chloride. Sodium chloride. It's stable salt. It's stable salt. NaCl, table salt. It means that this Na is formed of this is formed by ions, cations and anions. So such compound which is formed by ions is known as ionic compound. Ionic compound. Cation is positive, anion is negative. Okay then, see you in the next one. Take care.